Alright, this video is going to be on graphing cube root functions, and so obviously a cube root has a different index than a square root. A cube root looks like this, so remember we have the radical, but then the index has a 3 right there. So we're going to talk about what kind of functions can you get, or what do the functions look like when you're graphing a cube root function. A couple things about a cube root before we actually go to the graph. Remember that a cube root you can take the cube root of a negative number, like -8, or you can take the cube root of a positive number, like +8. And so remember, cube root works not only for positives but also for negatives. So this one would be -2 and this would be +2. So in essence, when we look at this function y equals the cube root of x, what we want to realize is that you can plug in any number for x because of the fact that you can cube root any number, both positive and negative. So when we make a table for this, you're going to actually need both positives and negatives, and you want to pick perfect cubes. For those who don't remember what perfect cubes are, I'll write down a few, but you're really only going to want to use a couple of them. Perfect cubes are 1, 8, 27, and then 64, and then 125, and I can't go past that. What's that, 216? I could be wrong. I'd have to double check. Don't have a calculator. Anyway, or the negatives, right? So plus or minus 1, right? Plus or minus 8, plus or minus 27. Those actually will work. But really, I only stick with trying to figure out when I'm graphing cube root functions. I really only use 1 and 8. Oh, I forgot about 0. 0 also works. So when I'm trying to put in x values, I use -8, -1, 0, 1, and 8. And so then I'm just going to plug those numbers in and get y values. So when I take the cube root of -8, that's -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And cube root of 8 is 2. And I'm going to plot all those points on our coordinate plane. -2, -1, -1, -8, -2. And that's what the graph's going to look like. It's kind of tough to draw in one part. So what I do is I start in the middle, and I draw it that way, and then I start in the middle again, and I draw it that way. It's one continuous graph, and the domain is all real numbers, so -infinity to infinity, and the range is also the same, all real numbers. Alright, so a cube root graph is slightly different, actually a lot different than a square root graph, because a square root graph doesn't have a domain and range of all real numbers. You can't use certain numbers, and so in essence, a cube root function you can, and it goes all the way to the left and to the right and up and down. But you need 5 points to graph this. So let's just take a look at one where you may have to do it by hand, where it's shifted a little bit with its transformations. So let's go with the graphing form first. Your graphing form will look like this. Y equals a, and then the cube root of x minus h, and then plus k. So the middle of the graph, the middle point, can be found by figuring out what h and k are. And that'll be your center point of that graph, where 0, 0 was on the first graph. And then you'll have to find more points by hand figuring out perfect cubes. And so let's give it a shot. Alright, so for this example, let's go with y equals the cube root of x plus 1, and then we'll go with minus 2. Alright, so the middle point is going to be -1, -2. We'll graph that, -1, -2. And then what we want to do is we want to get the 4 other points. And the way that you get those 4 other points in your table is you want to pick x values that create perfect cubes. And to make your life easier, the perfect cubes you should be trying to create are -8, -1, 1, and 8. That way it'll fit easily on the graph. So if you think about what number could I plug in for x here in order to get -8, that x would be -9, because -9 plus 1 is -8. What could I plug in for x to get -1? That'd be -2. What would I plug in for 1 to get, or excuse me, plug in for x to get 1? That'd be 0. And what could I plug in for x to get 8? That'd be 7, because 7 plus 1 is 8. And so now you have your x values, and you can plug them in and let order of operations take over. So -9 goes in, that's -8. Inside the radical, we know that the cube root of -8 is -2. And then you have to subtract the 2 that's at the end, so -4. So -9, -4. And then -2 goes in, that's -1 on the inside. Cube root of -1 is -1, so that's -3. So -2, -3. 0 goes in, that's 1, so it's cube root of 1, which is 1. And then 1 minus 2 is -1. And then, last one, 7 goes in, that's 8, cube root of 8, that's 2, 2 minus 2 is 0. So as long as you use these perfect cubes, you should walk away with a nice looking graph. Just remember the middle point is at HK, and that the perfect cubes that you want to create underneath the radical are -8, -1, 1, and 8. And it should be able to give you a graph that looks like this every single time. I'm not great at drawing them, so that looks pretty awful. So hopefully in class you'll see a more beautiful picture. I'll get better at drawing them. But have a wonderful day, and talk to you later.